So lastly for today, we're going to talk about formal charge. When we write our Lewis dot structures, sometimes atoms may not have a formal number of electrons that's equal to the valence electron count. And what you'll see is it will have a positive symbol or a negative symbol. Again, all this means is that that particular element has either less electrons or more electrons than it would normally in its valence electron count. A positive symbol is referring to less electrons. If something's positive, it's lost electrons. And the negative symbol refers to it having extra electrons. It's gained electrons. So in the case when this happens, we call this atom having a non-zero formal charge. Now, there's a way to calculate this. Generally, what you're going to do is subtract the valence electron count of the atom, normal atom, from the formal valence count. That's going to be the actual number of electrons that are present on that atom in a molecule. This is going to give you the formal charge. We're not going to see any formal charges with magnitudes greater than 1 in organic molecules. So generally, you're either going to see a +1 or a -1. To calculate the formal charge, first we're going to calculate the formal valence electron count of an atom. Again, this has a fancy name, formal valence electron count. This is just the number of electrons that are around that atom, either being shared or just on the exterior. So you should count all unshared electrons and half of bonding electrons. These, again, are just the electrons that are what we're going to be calling are owned by that particular atom. So you can see example here. If we want to look at hydrogen, hydrogen has no unshared electrons, but it does have shared electrons. Here are its shared electrons. There are 2 shared electrons, and we're going to half that, which means that its count is 1. For this carbon here, carbon does not have any unshared electrons, unbonded electrons on it, but it does have a lot of shared electrons. So let's look at all of carbon's shared electrons. 1, 2, 3, 4, 5, 6, 7, 8 shared electrons, and we're going to half that, 4. Now, if we look at the nitrogen and the oxygen, these already have their plus and minus symbols on them, so you already know what we should be getting, but let's count them anyways. So this oxygen at the top in pink, it has 1, 2, 3, 4 electrons that are unshared. That's where this 4 comes from. It also has 1, 2, 3, 4 electrons that are shared. And we're going to half that, so that equals 2, ultimately giving us a 6 for its count. For nitrogen, this nitrogen here does not have anything that is unshared, but it has a lot of shared electrons. 1, 2, 3, 4, 5, 6, 7, 8 shared electrons. Cut in half is 4. That's its number. And then for oxygen, oxygen here has 1, 2, 3, 4, 5, 6 electrons that are non-bonding, and it has 2 that are part of a bond. When we cut that in half, that equals 1. So 6 plus 1, 7 here. And we got a lot of numbers. What do those numbers mean? Well, if we go by our formula shown before, here again is that formula. We're going to take the numbers we counted, and you're going to subtract from the valence electron count, the normal valence electron count of that atom. So for hydrogen, for example, hydrogen's normal valence electron is 1. 1 minus 1, 0. It has 0 formal charge. That makes sense. There's no positive charge on it or negative charge here. For this carbon, carbon normally has 4 valence electrons, and the number we calculated for it here was 4. So 4 minus 4 also equals 0. This oxygen in pink, oxygen normally has 6 valence electrons, and we calculated 6 here. 6 minus 6 equals 0. What about this oxygen in green? Neutral oxygen has 6, but we calculated 7 electrons around it. So 6 minus 7, that's a -1. So its formal charge is -1. It gets a negative symbol by it. Nitrogen, its normal number of valence electrons is, in this case, 5. And the number we got for it was 4. So this equals 1. So its formal charge is a +1. And that's where it gets its plus symbol from. So this is just a way to calculate if your compound should have a plus or minus on it. Another way to kind of go about this, you can always use this formula to calculate formal charge. If you're unsure if something should have a plus symbol on it or a minus symbol, use this formula. But I would say stay on the lookout for patterns. So there are a lot of patterns associated with formal charge. 2 of them are here, and you'll see these a lot. So nitrogen usually likes to make 3 bonds. And in this case, it's making 4 bonds. So a nitrogen with 4 bonds almost always has a positive formal charge. Oxygen usually likes to make 2 bonds. We discussed that earlier in our Lewis dot structures. In this case, you actually see that the oxygen is only making 1 bond. So if you see oxygen with 1 bond going to it, oxygen with 1 bond, that's a common pattern for oxygen with a -1 formal charge. So those oxygens will almost always have a negative charge on them. So again, look for these structural patterns. So let's do another practice. Now, something I had told you already about Lewis dot structures, if we normally look at nitrogen, if we wanted to draw NH4 without using our pre-distinguished compound here, we know that nitrogen has 1, 2, 3, 4, 5 valence electrons. 3 of those are left unpaired, meaning that nitrogen usually likes to make 3 bonds. But here we have it bound with 4 hydrogens. To do this, we actually have to remove an electron. If we remove an electron from the valence shell, Nitrogen only has 4 valence electrons. 1, 2, 3, 4. Now it can make 4 bonds. But remember, we had to remove an electron. When you take away an electron, you leave a positive charge. So this is another way to think about your formal charge. Again, it follows the pattern that I said on the last slide, that when nitrogen has 4 bonds to it instead of 3, that means that you have a positive formal charge. We can also use our formula. So doing this using the formula, I'll show you now. If we draw our structure as shown above, like this, okay? So this hydrogen here is making a bond. It has 2 electrons in that bond, meaning that its formal valence number is going to be 2 times 1/2. Remember, we're going to half each electron in a bond, which equals 1. This hydrogen up here, it's the same thing. And for all the other hydrogens, we have the exact same situation. Okay, now for our nitrogen. Nitrogen does not have any lone pairs around it here, but you can see that it has 1, 2, 3, 4, 5, 6, 7, 8 electrons total in bonds. And their bonding electrons, so we're going to do by 1/2, and that equals 4. Okay, so here we are just calculating the number of formal valence electrons. Now we're going to subtract our number of formal valence electrons from the number of neutral valence electrons. This is the number that you would find on the periodic table, the number that this element normally has. In the case of hydrogen, hydrogen normally has 1 valence electron. So for this hydrogen, that's 1 minus 1, 0. All these other hydrogens, it's the same case, 1 minus 1. And here. Okay. So you can see these all have a 0 formal charge. They don't have a charge on them. But for nitrogen, as we talked about before, its valence number is going to be 5. That's 5 minus 4 equals 1. So it has a positive 1 valence formal charge, meaning that this structure should look like this. Okay, so again, 2 ways to think about your formal charge as a reminder. I, again, like to use this method on the left. I like to think about where my electrons are sitting around the atom, draw them out individually, and how many bonds that will make. I like to use the pattern of knowing that nitrogen that has 4 bonds is always going to be a positive charge. But mathematically, you can always solve it as shown below. Okay, well, that ends this particular review lecture. If you have any questions, please feel free to ask them always on the discussion board or via email. And also, if any of this is unfamiliar with you, please review it. Go to your book, read the section in chapter 1, and make sure you understand these concepts before we kind of build on them for the next concept.